Hey guys, Justin here. Thought I'd do a quick class on using EasyEDA to prototype on a breadboard. So why would you want to do that? Well, if you've ever done circuits on a breadboard, if it's a small schematic, it can be quite easy. You can get it up and running quickly. But once you start adding a decent amount of components, you can run into some issues with getting everything connected up right. So if you use a program like EasyEDA, you can pre-lay out everything, which makes it easier to assemble it on the breadboard, and you can make it look nice, and it makes it a lot easier to troubleshoot. The other good thing about it is, I'm sure there's other software out there that lets you simulate a breadboard, but if you do it in EasyEDA and then you get your circuit working perfectly, then you can have a lot of confidence when you go to order a PCB that the circuit's going to work and that you got your schematic correct. So to start out, here's a quick small but not too small circuit that we're going to put on a breadboard, and I'll show you how to do it. In order to prepare for it, you'll notice that I don't have jacks here for the input or the output, and I don't have like the power header connector, all those kind of things. So we want to set it up, for the breadboard. So instead of having a jack for the input, I just have a single point here. So that gives me that pad that I'm going to use to connect the input into the breadboard. So once we have our schematic done, we're going to save it. And actually, right before I save it, I want to do an annotate real quick, which is going to redo all my numbers. You see I got R1 here and R2 here, so it's a little messed up. So I'm just going to hit annotate, edit annotate, and that's going to relabel all of our resistors to help us out a little bit. Alright, so now I'm going to save the file again, and I will generate a PCB for this project. And here we go. Alright, so we're not really worried about the outline yet, so we can just hit cancel here. And I'll show you what I like to do to set up for my breadboard. First thing I'm going to do is grab all this stuff and move it a little bit out of the way. There we go. Okay, so if you look at your normal breadboard, you've got 2 power lines at the bottom and 2 at the top, and then you've got all your pins in the middle. So we're going to simulate that by drawing on the silk screen layer. So I'm going to click on the top silk layer, and I'm going to do a wire. So we're going to, one first thing I neglected was to set up our snapping, right? So the grid size, we want it to be 100 mils, or 100 mils is what we want, which is a 0.1 spacing for your typical breadboard. So we're going to make sure that that's set. It was already set, and we're also going to snap to that for right now. There we go. Now we're going to select our top silk layer and a wire, and we're going to draw a net, or draw a trace here. It can be however long you like. That's going to be longer than we need. And we're going to do that again right above it. Oops, I messed that up somehow. Let's do that. There we go. And then we're going to label these guys. So we're going to put text here. We'll call this one ground. And actually that's going to be the top one. And then I'm going to copy and paste that. And I'm going to call this one plus 12 volts. Or actually, sorry, let me switch that up. Let me put minus 12 volts here. Now this is going to depend on how you have your breadboard set up, right? So that can vary from case to case. So now, okay, so just to show you what I'm doing here, let me go quickly to a photo of a breadboard. So right now we've just drawn lines that represent these pins. The bottom one is the minus, which is the ground, and then we've got the top one is the plus. So that's going to be, or actually I've got them reversed in the breadboard. It depends on your orientation of your breadboard, which one you have plus and minus. So that can vary a bit, but doesn't really matter for what we're doing here. So we've got the ground on the top. Then we're going to skip a line, and you'll notice that there are 5 holes here in a normal breadboard. So we're going to do the same thing. we're going to click here. We've already got 1, 2, 3, 4, 5 holes, right? And I'm going to right click to end that trace. I'm going to do the same thing, right click, same thing, right click. So these are representing those 5 pins. And actually there's a little more space, so I'm going to snap this up one. Let's go. And it's not letting me. There we go. Alright, so, and then what you can do is you can start copying that and pasting it until you think you have enough spots. Of course, you could actually do exactly as many as you have on your breadboard if you like, but we're not going to need that many. Alright, so then in the middle here we have 2 empty spots, and then we're going to do the same thing. So I'm going to paste it again. That's the first one, second empty, and then that one. So we've got 2 empty holes here. So now we can check this by grabbing our IC and snapping it into spot here. Let's see. Now for the ICs, I notice it won't snap on the pins, so I have to change my snapping to half of the 0.1, which is 50 mils. Right, so now I can snap on there. You can see that the pins line up, so that's what we want. Right, we want the space between this to be the right amount so that an IC can go across that. And then the same thing here, we'll grab these 2 guys. And we'll do a Control C and a Control V. I'm just going to paste them right there. Alright, so on the top one, we'll put the ground, and we'll do plus 12 volts. So I'm going to change this label to plus 12 volts. Now notice that there are no connections. There's nothing connected yet. These are just representations, graphic representations of these pins. Alright, so we're going to paste that. Now what you'd want to do is create this breadboard and save it in a template file. Have a project that just has your commonly used stuff, and you can put that there. Alright, so let's get started actually using setting up our circuit here. So I know I've got the input. One thing I like to do is, let me grab these jacks here. We don't know what they are, right? So we're going to highlight them, and we're going to turn off the display name, and we're going to turn off the prefix and turn on the display name. So now I know that this pin is for the input. So we're going to put the input up here. So we've got our input coming in here, and then we know that it's going to connect to R1. So I'm going to lay R1 here on our schematic. Next we've got a, actually let me move it down a little bit. We've got a capacitor. If we look back at our schematic, C1 and C2 are involved in this input section here. So we'll grab C1, and you'll see that C1 is connected to there. So I'm going to put it on the same line. Now this isn't connected because the resistor is plugged into this pin and this pin, so this pin has not been connected yet. That pin is going to go to ground. If you look at it, this is for ground, right? So next we're going to grab R2, and that one connects to that. So let's go ahead and we'll move this capacitor there, and we'll put this one here. Remember, you want all your stuff to stay on the pins, so you want them to be on the intersections, right? Because those represent actual pins. Then we want C2, so we're going to grab C2 here, throw it over here. Same thing, this is ground, so we don't need to connect it. Alright, so we'll place this, and because we're going to have jumpers that go from this pin up to here, we want to leave this top row empty for now. So I'll bring this capacitor down here. So that gets us going on that. Let's see, these ones connect to, I'm going to flip this guy like this and just stick it right here. Let's see. So we've got minus 12 volts here, and we've got plus 12 volts here. So we got a couple options. We can run jumpers or we can flip these around. Now let's leave it as is. So now how we're going to use this is we're going to draw a blue bottom layer is going to represent the pins, right? So we're going to connect these with blue. This means that it's just plugged into the pins. There's no wires, right? Because this whole, and you can actually make the track like that if you like, right? You can imagine that the track is like that. I'm only going to do it on the pins where I actually have things installed though. So let's go ahead and connect this one to here. Like that. And then we're going to do this one to there. Now, how are we going to connect these grounds? We need to connect from ground up to here. So what we'll do blue up to this pin, and then we'll put a via right there, and we'll grab the top layer, hit W for wire, and we'll go up to here. For now, we don't need to worry about anything up here, right, connecting it. But we know that that red wire now goes to the ground, right? And we'll do the same thing over here, and we'll put a via in, and we'll do a red wire up to ground. So now we know that those are connected. And if you want to, you could connect those across, and then now they're really connected in the file. All right, so we need to connect this resistor over here to this pin. So the way we do that is kind of the same thing. We can just grab the red, put it here, and we're going to add a via in, and we'll do blue. Oops. Our bottom layer, right? So now we've got that connected. Now we know that this, excuse me, this minus 12 volts needs to come down here to this spot here. So how do we do that? Well, we can just put, we can go to the bottom layer and draw it up to here, and then we can put a via in and do our top layer over to here, put a via in, grab our bottom layer, and go down to here. Same thing as everywhere else. We'll put a via in, we'll switch layers, you see what I'm doing is I'm drawing a graphic representation of all the jumper wires, right? So right now, remember, blue means it's just a pin. There's no actual wire, but the red represents an actual wire. Alright, so now we've connected through these jumpers over here to this pin. We've connected minus 12 volts, which is what this one is, to the right spot. And we'll do the same thing on the other side. We'll do that with our blue. And remember, we can actually extend these if we want, just to remind us that that whole thing is energized on that track. And if we look here, this is the plus 12 volts, so we'll draw that guy. We'll put a via in. We can put it right here. Red, W for wire. Put another via in. Wire, we want to do the bottom layer, because now that whole, all 5 of those pins are now plus 12 volts, right? So that's why it's good to actually label them or draw the blue all the way across. And we'll put our little jumper here. Alright, so now we've connected the 12 volts up to here and the minus 12 volts down to here. Let me turn on, what we're going to do is go to Tools, Layer Manager, and we're going to make the top silk screen, let's try 25% transparency. Maybe that'll make it a little easier. Alright, so we're going to work on the next section. So if we look at our schematic, we know that we've got this part here we need to take care of, which goes on that first op amp side. So there's a trimmer resistor. That's one of those 25 turn, 20 turn trimmers, and we've got two resistors, 8 and 9. So let's go grab these guys. Let me grab this one, and we want 8 and 9. We'll grab those, bring them over here. So if we look at our resistor, we've got minus 12 volts and plus 12 volts on either end. So what I'm going to do is I'm going to grab this one and stick it right here. So now the plus 12 volts is already energized because that rail goes up to that row of pins goes up to the 12 volts. Alright, so then we can grab this one here, this resistor, and then we can grab this resistor here and connect those like that. Let's see what we've got going on here. Okay, so now we can wire in some of these connections. Now this one is an example, and actually what I'm going to do is move this down one. Oops, move it down to here. Move this down to here. Okay. Now I need to connect the minus 12 volts over to here. How do we do that? Well, the way I do it is I draw that blue bottom layer like that, and then I'm going to put a via in just like before, and now I want to make a wire come over to here. The problem we have is, of course, we can't cross the red with the red, right? So let me show you how you can add some more colors. Go to Tools, Layer Manager, and you'll see the copper layer says 2. We're going to change that to 6. Now we've got at the bottom, or actually we've got these inner layers right up here, all these different colors here. So now we can start using those to indicate different jumpers, right? So if you scroll to the bottom here, you'll see all of our different colors here. So I put a via already, so I'm going to grab inner 1, and I'm going to hit wire. And in this case, I don't care if it's exactly on line because this represents an actual jumper wire, so it can go in free space, right? Does that make sense? Hopefully. Let's look at our bottom layer here just so we can see. So now we've connected this minus 12 volts using a little jumper from there to there. What else do we have here? This one has to connect here. Okay, so what we'll do is we'll grab our bottom layer and we'll draw it out to here. Put a via in. Same thing, except we'll grab inner 2. It's another color, and we'll make it go up here, come over here, and down to here. Let's add a via. Go up to our bottom layer. And now we've connected these layers, or these two components over here. To make it a little easier, you can move your, easier to see I should say, you can move your labels here. Alright, so we're halfway done. We've got the one side of the op amp circuit complete. Let's start seeing what this one goes to. What I can do is I can place it right there, and then let me grab some other stuff here. R4, R6, let's grab these guys here. Oops. Just going to bring it down here so I can see it a little better from when I zoom in. Now, one thing I like to do is we know that if we look at our filter, we've got the same thing. R3 and R4 are the same. R3, R4, C3, and C4 are the same as the beginning here. So sometimes it makes sense to try to copy. on what we're doing. So instead of putting that there, what I'm going to do is put it over here. So that one, and then we've got R4, and then we've got C3 goes there, got C4, oops, let's put that there, C3 there. Okay, so let me show you how I'm going to connect this one. You'll see we've got the one long jumper that we need here, and they both need to connect to this pin. So let's go ahead and do that. Okay, I'm going to grab a different inner 3 here, the yellow. Come around here. Put a via in. If we go back and look, now that one's connected. So now we need to connect this one to this pin. So we can do the same thing. We can work on that inner 3 layer, and we can do a wire, and we can grab it. We can just go out into outer space here. I'll go back to actually I'll put a via there. Okay, so now we've got this wire here that goes all the way around and connects back into here. Let's add some more traces for this part. And I think it's helpful to not put blue on all of them, not to put the layer on all the pins, just the ones where they're connected, because that kind of helps you keep organized. So for here, we've got grounds again. We've got a couple options. We can go down to the ground at the bottom. So we'll put some vias in. And we will grab our red wires and connect to ground. Now you'll notice that these are still not showing as connected. Or you can see the blue line here. So normally on your breadboard you're going to connect your 2 grounds up. So I'm just going to do that here, like this, out of the way. Okay, and let's just connect those guys. So now those ground wires go away. All right, so we've got this row here needs to connect to this pin here. So we'll put a via in down here. We will go to inner 1, and we'll do a little wire here, like that. We'll add our via, and we'll go back to the layer, bottom layer, connect it, and let's see what we can do next. So we've got this R7. It needs to connect here, but you'll see that it's not going to work because we have it will hit this it will go to pin 8 on that op amp if we do that. So we can move it out here. This one will work, so we'll go ahead and do that, and we'll rotate this R7 here so those line up. And then we've got a capacitor here. Let's see. It needs to go from this one so let's see how we can do that. Let's see. Let's put it here. Okay. And we've got an output pin which we can just stick right there. And we've got a 5-volt pin that we need to put on here. So we'll just do this like that. Alright. I think we're set to do some connecting. We'll go to the bottom layer and we'll draw our line here. We'll draw our line here. We need to connect this pin, so we'll put a via. We can use the red layer for this one. And we need a spot here, right? So we're going to move this guy here. And we'll go back to our red layer, put a via, bottom layer, put a wire from there to there. Let's go ahead and connect these guys here. Oops. Let's do a via here and a via there. Sometimes this doesn't work. Let's see if it works. Yeah, it worked. Okay. And we just have one more connection here. This one, we're going to move this guy all the way up to here so that we got a little more room down here. And we'll connect with wire. Let's do a via at the end. Oops, didn't work. I think that's because I'm on the wrong layer. Let's go back, put a via. Alright, we got a problem. That one, it is connected. So what's the deal? Oh, okay, let me. Maybe it's this one. What's going on here? Okay, so I messed up, didn't I? These ones are connected, but not, yeah, not to this one. Okay, so let's figure this out here. Let me move this guy out of the way. It's always good to show when the presenter messes up, and let's see how we can fix it. The bottom layer, we're going to connect these guys. Okay, so those are all connected now. Now I need to run from here to this one, so I'm just going to rotate it twice. I'll put it right here. And I'll grab an inner wire. We'll grab from here. From there to there. Put a via. And then I can also do a via right here. And then we just need to do some connection here. Now if we look at our nets on the left here, they're all red X's, but when we hit refresh, you can see that they're all connected. So this represents our schematic on a breadboard, and we just have a few jumpers to install, not a million of them. I think it's pretty good. Let's take a look at the 2D view. For whatever reason, I always get a blank screen first. Oh, okay, wait, let's fix the 2D view. So we need to set our outline to match our schematic here. So what I'm going to do is I'm going to go to Tools, Set Board Outline. We're going to start at, I'm going to hit Cancel because I want to do it in millimeters. And I'll do it again, Tools, Set Board Outline. X is going to start at 0. We're going to make it 50 millimeters wide. Y will start at 75, make it 75 tall. And that's not big enough. Tools, Set Board Outline. So let's make it wider. Let's make it 75 wide and 50 tall. got my numbers backwards there. That looks pretty good. So now what we can do is we can do a 2D render. For whatever reason it always fails the first time, but this gives us our layout on our breadboard. Hopefully that makes sense. Now one thing I like to do is, I don't care too much about the R numbers, so I'm gonna select all these items here. Let's see if this works. No, it doesn't. What you can do before you move them onto the breadboard is change them to show the properties like that. So we'll put a 15K and so forth, and that way it makes it easier to put it on your breadboard, because you have the values of the resistors and the capacitors and all that stuff. And then just make sure all your outputs and inputs are labeled. So I'll need to bring 5 volts into this breadboard. Most breadboards only have 4 rails. I could have made one of these rails to be 5 volts, but I like to have ground on both of them. So and I needed a -12 and +12. So that's why I went this way. And then I would just bring 5 volts in from somewhere else. But anyways, hope you find this helpful. You can use this tool, and another great thing to do is, now that you're at this point, take a screenshot of this, open it up in your Paint program, and then you can, as you make these connections on your breadboard, you can use a pen, a marker, to mark on top of that connection on inside your Paint program, and that allows you to keep track of what connections you've made, which ones you haven't, because it can get a little confusing. But if you have this open next to you while you're doing the breadboard, that helps a lot. So anyways, this is just a quick video. I hope you like it. Let me know what you guys think about the format. Do you like it for me to go through every step? Would you prefer if it was shorter and it just kind of jumped from step to step and everything, or is the way I'm doing it the best way to do it? Any feedback is greatly appreciated, and if you have any ideas for future videos, feel free to let me know. Thanks for watching.